All right, today we're going to dive into what is, honestly, one of the smartest little tricks I've seen in 5G. It's a brilliant piece of engineering that makes reliable satellite internet on your phone not just possible, but practical. Let's get right into it.
I want you to just picture this for a second. Your cell tower, instead of being a stationary thing bolted to the ground, is a satellite hurtling through space at 17,000 miles per hour. That is the reality we're dealing with when we talk about connecting to low Earth orbit, or LEO satellites. And yeah, it creates a pretty unique challenge. So the big issue here is something the engineers call discontinuous coverage. It's exactly what it sounds like. These satellites are moving so incredibly fast that one will literally fly over the horizon and out of your phone's sight before the next one is in the perfect position to take over. This creates a predictable but very real gap in your service. So what does your phone normally do when it just suddenly loses its signal?
Well, traditionally, a phone that loses its connection pretty much panics. It immediately throws up a no service message and kicks off these things called destructive scans. It is frantically hunting, screaming into the void on every frequency it knows, desperate to find a new signal. As you can imagine, this is just a colossal waste of your battery.
And this slide really lays out the difference. On the one hand, you've got that old terrestrial panic mode we just talked about. But on the other side, when we're dealing with these non-terrestrial networks, or NTNs, the phone does something way smarter. Instead of freaking out, it goes into this special state, pauses a bunch of internal clocks, and it just waits.
The official name for this cool little trick is discontinuous coverage handling. And honestly, the best way to think about it is like this. The old way is like missing your bus and then running all over town totally lost trying to find another one. This new way, it's like you've got the bus schedule right in your hand. You see the bus leave, you look at your watch, and you know the next one is coming in just a few minutes, so you just wait patiently. It's a total game changer.
So how does the phone actually pull this off? How does it play this waiting game so intelligently? Well, it all boils down to a really simple but super elegant four-step process.
First, the phone either detects or, even better, anticipates that it's about to lose the signal. It knows the satellite's flight path. Second, and this is the absolute key, it hits pause. It enters that special state and stops all the internal alarm clocks that would normally trigger that panic search. Third, it just listens. Patiently, it monitors for the signal from the next satellite. And finally, boom. Once it hears that new satellite, it seamlessly reconnects and all its timers start right back up. Smart?
And when we say the phone pauses timers, we're talking about very specific things. These are the little clocks inside your phone's software, like T3502 or T3512, that are responsible for checking in with the network. By putting them on hold, the phone basically tells itself, hey, don't worry, we haven't been kicked off the network. We're just waiting for our next ride. It prevents that whole battery-draining panic before it can even start.
Okay, so that's the technical how. It's super clever, but let's talk about the why. Why does this one little change have such a massive impact on your experience?
The real-world benefits here are just huge. First off, by not panicking, your phone saves a ton of power. That means longer battery life. Simple as that. It also cuts down on all that useless network chatter, which makes the whole system more efficient for everyone. But the most important thing is that it creates a stable, seamless connection. This transforms satellite internet from what could be a choppy, frustrating mess into something smooth and reliable, whether you're climbing a mountain, on a plane, or out in the middle of the ocean.
And that really brings us to the final, bigger idea here. This isn't just about saving a bit of battery. It's about fundamentally changing what losing a signal even means. It's no longer a frustrating emergency, it's just a managed, expected pause. And that makes you wonder, right? It forces us to ask a much bigger question. What will we be able to build when a lost signal truly becomes a thing of the past?